Welcome back, everyone. Today, we're diving deep into a choice that literally makes or breaks electrical routing for MEP engineers and EPC project managers. We're talking about busway versus cable tray. We're not just deciding on what materials to buy here, we are looking at the foundational logic that determines whether your entire project succeeds or fails.
Listen up, because we really need to sound the alarm right off the bat. If you're comparing these two systems based purely on their cost per meter, you are walking straight into a massive trap. It's a fundamental misconception, and honestly, this kind of surface-level penny pinching is the exact reason why so many EPC projects run into giant, expensive problems down the line.
Okay, let's dive into this. To give you a clear roadmap today, we're going to hit 6 key areas. First, we'll bust that cost per meter myth. Then, we'll look at the core engineering differences, exactly when busway wins and exactly when cable tray wins. After that, we'll walk through a 6-step decision sequence and wrap up with global manufacturing standards.
All right, part 1, busting the cost per meter myth. We really need to unlearn some bad habits here before we lock in any routes.
The truth in the source material is pretty blunt. It says, forcing one to do the other's job, or comparing them only on cost per meter, is exactly where EPC costs and schedule problems start. If you fall into this comparison trap, your budget is going to blow out, and your schedule will be completely derailed. Why? Because you are literally buying 2 completely different functions.
Which brings us right to part 2, the core engineering differences. Let's look at the actual mechanics of what these systems do.
This brilliantly illustrates the core issue. On the left, you've got busway, which is fundamentally a current-carrying system. It directly transmits the power. But on the right, you have cable tray, which is simply a cable support pathway. Trying to make them compete on the exact same route is literally like comparing apples to oranges. They solve entirely different problems.
So, knowing that, let's move into part 3 and look at when busway actually wins.
You might be wondering, what are the specific scenarios where busway is the undeniable, absolute best choice for your engineering project?
It comes down to these 4 critical criteria. First, high current feeders. When you have massive power demands, busway's efficiency is just unmatched. Second, tight risers. When your space is heavily restricted, its compact footprint is an absolute lifesaver. Third, repeated top-offs. And finally, stable layouts. If your project demands these specific criteria, busway is absolutely the undisputed champion.
To keep things perfectly balanced, we need to flip the coin. Part 4. When cable tray wins.
So, mirroring our last question, when exactly does cable tray step up and dominate the field?
What's really interesting here is the totally different underlying logic. Cable trays completely dominate when you need to run mixed cable types, like, say, putting power and control lines in the exact same path. They're also perfect for field flexibility, when you have to adapt on the fly, when you need direct visual inspection, and for complex branch wiring. Basically, when adaptability and visibility are paramount, you can't beat cable tray.
Now, how do we turn all this into action? That brings us to part 5, the 6-step decision sequence, purpose-built for EPC and MEP teams.
This is your ultimate pre-lock checklist. Let's walk through it methodically. Step 1, seriously stop the cost per meter comparisons right now. Step 2, accurately assess your actual current carrying needs. Step 3, assess your physical cable support needs. Step 4, verify if you're looking at a true busway scenario based on what we just covered. Step 5, do the exact same verification for cable tray scenarios. And finally, Step 6, lock in the optimal route. Skipping even one of these steps is practically a guarantee for poor routing choices.
Once you've made your decision, you have to actually source the materials. So let's look at part 6, manufacturing standards and global compliance.
So the crucial point here is credibility. If we look at a manufacturer like Xinma, you can see their comprehensive capabilities. They've got everything from cable trays and busways to seismic bracing and intelligent solutions. And they apply these across data centers, rail systems, industrial plants, and commercial buildings. But the real takeaway, they anchor all of these diverse solutions in strict global standards, like IEC, NEMA, and GB standards. That is your baseline for quality.
And that brings us to the end of today's deep dive. But before we go, I want to leave all you engineers and procurement folks with one final critical question. Before you lock your next route, are you designing for the absolute lowest cost per meter, or are you actually designing for the right engineering fit? Hopefully this framework helps you make the smartest choice on your next build. Thanks for joining me on this explainer.